Last ever section of geometry. You made it. All you got to do is turn everything in and you are good to go. So this is your last section. So what I'm going to do is I'm going to go through the definitions of these things. This is section or chapter 11.8. This is all about spheres. Spheres are shapes that look like a ball. Okay? So if you can't see this 3D shape, just pick up a baseball, a basketball, a tennis ball, anything that you got near you that looks like a ball, and you're good. Okay? A sphere is a set of points that are a given distance from a given point. It looks like a ball. So this C is what we're talking about. Everything around in the entire shape is given by that point, or given around that point right there. Every single piece is equidistant around that thing. Okay? A sphere is the point in the middle. And I should say the center of a sphere is the point in the middle. So that is point C. C is the point in the middle. Alright? The radius of the sphere is a segment. It's a segment from the center to the outside. So like CB would be an example of a segment. So like if we wanted to draw that or look at it, I'm sorry, not a segment, radius. CB, this thing right here, is a radius. That's what a radius looks like. Okay? A chord of a sphere. A chord of a sphere is a segment whose endpoints are on the sphere. So that's what's going on down in the bottom down here. We're not going to deal too much with these. This would have been in the next chapter if we actually got to it. But this is talking about DE. DE is on that sphere. Okay? A diameter of a sphere, this is kind of straightforward because it's just like a circle. A diameter of a sphere is a segment that goes through the center. So like the example of this would be AB. AB goes through the center of the sphere. Okay? Great circle, again, this is something that we would have dealt with a lot more in the future, but since we don't have as much time to do that, we're just going to have to do it like this. The great circle is the longest circle on the sphere. Think of it as like an equator. So think of this thing as like an equator, and what it really looks like is this thing right here. This thing is the great circle. It's the center of the sphere. It is it's like the equator going all the way around. Okay? And then a hemisphere is a half of a sphere. So those are all the definitions that we're going to be dealing with. Now it turns into just formulas. And then once we get through the formulas, it's all just practice, practice, practice. Alright? So we're going to go through the formulas of these things. If you know the formulas, you're good. Really, all we're going to have to do is find the radius. Once you find the radius, you're good to go. And you already know how to find the radius 99% of the time, so you're good. Okay? Surface area of a sphere. The surface area of a sphere is 4 pi r squared. Surface area of a sphere is 4 pi r squared. That's how much is around the outside. So like if you think of a baseball, think about how much leather is required to go around the outside of a ball. If you think of a golf ball, the white part is the surface area. If you think of a basketball, the leather around the outside is the surface area. Okay? Volume of a sphere is given by this. 4/3. You can't see that 3. It's 4/3 times pi times r to the third power this time. Not squared, to the third power. And then what a sphere looks like, it's got a point. And then I'm going to draw a big circle around the outside. And then the way that you do this is you start on one side and you make one line go underneath, and you make one line go behind, and you make the line that goes behind it dotted. And that's a sketch. Okay? A hemisphere, we just said that the hemisphere was a half of a circle. So the surface area of this thing is given by 3 pi r squared. The volume is given by 2/3 pi r cubed. And the way that you draw this is, again, you draw a circle like this, and then you just draw like a half moon on the bottom. Alright? And that's what we're looking at. 4 formulas, and you are all done with geometry. All you got to do is plug it in the right spot and use the correct radius, and you are all good to go. Okay? So let's look at an example. So like for instance, this first one, we have a diameter of 8. If we have a diameter of 8, that means that we have a radius of 4. So we've got a radius of 4. Now it wants us to find the surface area of this thing. So I look at my surface area, which is 4 pi r squared. So I'm going to do 4 times pi times the radius, which is 4, squared, and then I'm going to type it all into my calculator, hit the equals button, and it comes out to 201.1. If you don't trust me, type it into your calculator, hit the enter button, and make sure that it works. If it doesn't match up with what I got, say, hey, Mr. Shepard, it doesn't match up with what you got. Okay? So this one says that the great circle, this circle in the middle, has a circumference of 15.5. We know that the circumference is equal to 2 pi r, right? So 15.5 equals 2 times pi times r. So the circumference is equal to 15.5 equals 2 times pi times r. So I'm going to divide both sides by 2 pi, divide by 2 pi. So I'm going to end up getting r equals 2.5. So 15.5 divided by 2, hit the enter button, and then hit divided by pi, hit the enter button, and you get 2.5. Now all we're going to do is find the surface area of this, so it's going to be 4 times pi times the radius, 2.5 squared, and that's going to equal 78.5. Alright? And then I'll leave the last one for you because it's the exact same as the first one, except instead of 8 it's 20. So let's look at this one. So this is very, very similar to what we just did, except instead of using surface area, we're going to use the volume formula. So the first one, actually let's do the last one this time. The radius of this one is going to end up being 2, right? Because the diameter was 2, or 4, so the radius is going to be 2. So now we're going to look at the volume formula, so it's 4/3 pi times the radius cubed. So I'm going to type in my calculator 4/3 times pi times 2 to the third power. You got to hit 2 caret 3. When you do that, you end up getting, gotta get the right page out. When you do that, you end up getting 33.5. So when you do that, you get 33.5. Right? So that's it for surface area and volume of a sphere. Now we're going to go to surface area and volume of a hemisphere, which I didn't put that one on there. Give me 1 second. Let me get that pulled up. So let me get that pulled up. So let's look at a hemisphere. So let's look at this one. So now if we look at a hemisphere, radius 25. If I want to do surface area, I just look at the surface area formula for a hemisphere, and it's 3 pi r squared. So it's going to be 3 pi times 25 squared. So 3 pi times 25 squared. When you hit the enter button on that, you get 5,890.5. Now please use your calculator. Don't make this any more hard than it needs to be. Just plug this stuff in, hit the enter button, and be done with it. Okay? Now the next one, if we do volume of a sphere, or a hemisphere, it's going to be 2/3 times pi times the radius cubed. Again, type it into your calculator and hit the enter button. It's 32,724.9. Okay? And that's it. So that's it for hemispheres. Now the very last thing that we can do, this is very similar to what we did on the area worksheet a long, long time ago. But what you're going to do is you're just going to find all the pieces and either add them or subtract them. Okay? So it doesn't really matter which one you do. I have all of these worked out so you can see them from start to finish. I'll go through, I guess, the cylinder one because I think that one's going to be the trickiest. But if we look at this one, it says 4 tennis balls are stored in a tube. What's the volume of the space not taken up by the tennis balls? So the first thing I'm going to do is I'm going to find the volume of the cylinder. And then I'm going to take away the volume of all 4 spheres. So basically what I have to do is I have to find the volume of this, and I have to find the volume of one of these spheres, and then just take that away from the cylinder 4 times. So my sphere, the way that I find that, is going to be 4/3 times pi times my radius, 2.2, to the third power. Okay? So now I'm going to do 2.2 to the third power. Oh, hang on. Nope. It's not 2.2. It's 2. Sorry. To the third power. When you hit the enter button on your calculator, you end up getting 33.5. Now, what I'm going to do is I'm going to multiply that by 4 because there's 4 tennis balls on the inside, right? So now that's going to be 134. So the volume of the tennis balls is 134. Now if I want the cylinder, remember it's just pi r squared h. So it's going to be pi times the radius, 2.2, squared times h. So pi r squared h, and that's going to be 258.5. So 258.5. And now I'm just going to subtract them. 258.5, taking away the tennis balls, 134. And that's going to equal 124.5. And that gives me my volume. Okay? Now again, that's it. I'm going to leave the rest of the examples up to you to finish. If you have any questions, ask me about them, say something, talk to me about it, and say, hey, I don't understand what's going on at all. Please make sure that you let me know. Okay? It's been a pleasure teaching you guys this year. I'm bummed that I didn't get to say goodbye to you guys in person, but I'm sure I'll see you around the halls next year. Please let me know if you have any questions. Please let me know if anything doesn't make sense, because I'd love to hear from you. I'd love to help you out if I can. Alright? So I will see you guys next year as juniors. We'll see you later.